Today I want to go over properties of exponents. Okay. So first of all, what is an exponent? Well, it's just a shorthand or notation, and it's used to describe the number of times a number is being multiplied by itself. So in this instance here, we have x times x times x times x. Okay. So a shorthand way to say that is x to the fourth. Okay. And this is very useful notation because sometimes you're going to have x to the 100. Would you want to write out 100 x's? No. So this is really great notation. And it goes along, it fits in with all of the other algebra that we've been doing. X in this instance is called the base. Sometimes you'll hear it referred to as the base. And the number 4 is commonly called the exponent or the power. Okay, you're raising something to that power. This is x raised to the fourth, or x to the fourth power. Okay, and there are 6 properties that I think are very important when talking about exponents. And these properties allow you to manipulate algebra problems. Okay. So let's go through our first property. The first property is called the product rule. Okay? Or rules are properties. So this is the product rule. And it states that x raised to some power a times x raised to some power b. Okay, so notice that the same base x, that's the same number. That's equivalent to a, or x raised to the a plus b power. Okay, so let's go over why that would be through this example. Okay, example. We have 2 squared times 2 to the third. So if we just followed this rule blindly, we'd say that that is 2 to the second, 2 to the raised to the 2 plus 3 power. And if we reduce that, we get 2 to the 5th power. Okay, let's see why that makes sense. 2 to the second is shorthand notation for 2 times 2. And then what we're doing is we're multiplying it by, what is this? This is shorthand notation for 2 to the third power. So this is 2 times 2 times 2. Okay. Now if we wanted to write this in shorthand, okay, using exponents, we would write this as 2 to the 1, 2, 3, 4, 5, or 2 to the 5th. Okay? So these, our rule here, it makes intuitive sense. All right? One thing that you need to be aware of is you cannot, say I have x to the a times y to the b. Okay, this doesn't equal, xy to the a plus b or anything like that. There's no rule that's going to help you out with a scenario like this. All right, so that's one thing to keep in mind when using the product rule. They have to have the same base. The next rule I'd like to go over is the quotient rule. Okay. And the quotient rule is very similar to the product rule, except it deals with division here. If I have a to the, or x to the a over x to the b, remember, same base, that's very important here. That's going to be equivalent to x raised to the a minus b. All right? So let's see why this rule makes intuitive sense. If we just followed this rule blindly using this example, 2 to the third over 2 to the second, we would know that this is 2 to the 3 minus 2, okay, or 2 to the first, which is 2. Okay, let's see why that makes intuitive sense. Okay, 2 to the third. Well, that is 2 times 2 times 2 over 2 to the second. I'll use another color here. Over 2 to the second, which is shorthand for 2 times 2. All right. let's do some canceling out. I have the same stuff on the top and the bottom. I can cancel out this 2 on the top and the bottom, and this 2 on the top and the bottom. And what does that leave me with? 1 2 on the top, or 2 to the first, or just a regular old 2. So this property makes intuitive sense. Okay? Let's move on to our next property, the power rule. Okay? And that states that if I have x raised to the a power, and then I raise that whole entire thing to the b power, that's going to be equivalent to x to the a times b power. Why does that make sense? Okay, using this example, we have 2 to the second raised to the third power. So if we just follow this rule blindly, we get 2 to the 2 times 3, or 2 to the 6th power. Okay? And that's equivalent to 64, but it doesn't really matter that much. Okay, well, let's look at this intuitively, like taking it out of our shorthand. So we have 2 times 2 here. That's what 2 squared is. And then what does this say we're doing? This 3 says that we're going to take that 3 times. We're going to do 2 times 2 3 whole times. So this is 2 times 2 times 2 times 2 times 2 times 2. All right, if we take our parentheses away, this is just 2 raised to the 1, 2, 3, 4, 5, 6th power. Okay, which is also equivalent to 64. Right? That is why that makes it intuitive sense. You're taking 2 to the second and you're taking it and multiplying by itself 3 different times. Okay, that's what this exponent highlighted in green is telling us. Okay, on to the next rule, and that is the negative exponent rule. Okay, here we have x raised to a negative power, negative a. Well, what is that equivalent to? That's actually equivalent to 1 over x to the positive a. Let's take a look at why that makes sense using this example. If I have x raised to the negative 2, okay, well, I can do some fancy math manipulations, and I can say that's equivalent to x to the 0 minus 2, right? 0 minus 2 is just negative 2. So that's no problem. I can do that. Now, this kind of looks like, if we go back, this kind of looks like what we had here in our quotient rule. It looks like x to the a minus b. So I can bring it and make it look like a fraction. Let's do that. So that's x to the 0 over x to the 2. Okay? And as you'll learn later, actually I think it's the 6th rule. I didn't put these in very well good order. X to the 0 is actually 1, and I'll prove that later on. And that's going to be over x squared. So we can see that x to the negative 2 is equal to 1 over x to the positive 2. All right? Rule number 5, the rational exponent rule. This one is a tricky one that kids always forget. If I have some fractional exponent here, so I have a raised to the b over c, okay, that can be written in 2 different ways. And each way can help you in certain scenarios if you have to hand calculate something. So it can equal the cth root of a raised to the b power, or it can equal the cth root of a all raised to the b power. Okay? And it's good to know both of these, all right? And I'm just going to try to show you why this makes a little bit of sense using an example. First, I'll calculate 3 raised to the 1/2 times 3 raised to the 1/2 using fractions, okay, using our product rule. And then I'm going to show you using radicals. Okay, so I'm just going to use the product rule here. This is going to be 3 to the 1/2 times 3 to the 1/2. Okay, and 1/2 plus 1/2. Well, that's just 1. So this is 3 to the 1st power. or 3. Okay? What this rule is saying is that this can be rewritten as the square root of 3. So there should be a little 2 here, but square roots are so common that you do not commonly see a 2 written there. But this is the square root. That's what it's called when something is that's the root, the square root. Okay. So this is the square root of 3 times the square root of 3. Okay. Well, this is equivalent to, you can multiply these underneath the radical. This is the square root of 9, and we know that the square root of 9 is 3. Okay, so it makes intuitive sense. All right. Next rule. I'm going to take the white paper. Okay, is the 0 power rule. Okay, so this rule we used to help us out in a previous example. Okay, so we know that x to the 0 or any number to the 0 power is equal to 1. Why does that make any sense? Well, let's use this example and try to figure it out. All right. So again, I'm going to use some fancy math. I'm going to say that a to the 0 power, I can rewrite that as a to the 1 minus 1 power, right? 1 minus 1, that's 0. Okay? So right now that right here, this right here, 1 minus 1, that kind of reminds me of that quotient rule again, but backwards, right? So I know I can rewrite a to the 1 over, or a to the 1 minus 1 as a to the first over a to the first. All right? And I also know, from, I don't know when, 8th grade math, maybe even sooner, that, actually maybe, not sooner, earlier, way earlier, a to the same number of the same number, well, that is just 1, okay? So any number, a is just a generic number, any number to the 0 power is equivalent to 1. All right, that's all the rules I have for you, and thank you.